Hi there, Mr. Sutton here, and you're joining us for a lesson on translations. We're going to be performing translations on the absolute value and square root functions, and we're also going to throw in all the other transformations at the same time after we've got translations down. For our real-life application, we'll talk about a cost scale for a license. For our warm-up, we're going to get a little more comfortable with the functions you're going to be working with on this one. So pause the video and take a sec to complete this table, and then graph the function. All right, let's see if we got the same thing here. So absolute value of -1 is 1, absolute value of 0 is 0, absolute value of +1 is also +1. So we've got -1, 1, 0, 0, 1, 1, and those 3 points are enough because we know what absolute value looks like from our lesson earlier on. Next up, pause the video, take a sec to complete this table for the square root function, and then graph it. Okay, so we've got square root of 0 is 0, square root of 1 is 1, and square root of 4 is 2. So graphing those, 0, 0, 1, 1. Notice that absolute value graph also has those 2 points, but that third point, 4, 2, makes this look a little bit different. So let's talk about some new material now. Translations, that is a move or a shift of the graph in a certain direction. We're not changing the way the graph's facing or the size, only the location. In order to explore these, take out your graphing calculator and experiment with adding and subtracting numbers inside and outside the absolute value and square root functions. Then go ahead and fill in these blanks here. So if you're having trouble finding the absolute value function, first off, let's go to y equals here. You can find the absolute value function in the math menu under number. It's the first one, abs. And here is the normal absolute value function. I'm just going to go to zoom 6, standard zoom window. Now let's go back to this, and let's do absolute value of, say, x plus 2. So we got x plus 2. There we go. And let's graph that. And it looks like that moved us left here. Now if we go back there and instead of adding 2, subtract 2, and then regraph that, looks like that was the original, and this is the new one. That's moving us to the right, too. So it looks like, at least with absolute value, that adding something inside moves us left that many units, and subtracting something moves us right that many units. We're going to use the square root now. If you haven't already done this, you can just watch along here. We're going to use the square root to add things outside the function. So let's go back to the calculator. And I'm going to clear out what I had there before. Now I'm going to do the square root function. So that's second, and then the square button there. Square root of x, and here's what that looks like. No surprise. Now I'll go back to y equals, and let's add some things and subtract some things outside the function. So first I'll add 2 outside the function and see what happens. It looks like that's shifting us up 2. And then if we go back and subtract 2 instead, this probably won't come as a huge shock. There's the original, and now we are shifting down 2 with that. So adding something outside shifts us up. Subtracting something outside shifts us down. So we're seeing kind of the same relationship here that we saw with the dilations. The inside changes are left-right. They affect the horizontal, and they're the exact opposite of what we expect. Adding inside shifted us in the negative direction. Subtracting shifted us in the positive direction. Outside changes, on the other hand, affect the vertical, the up-down, and they do exactly what they look like. Adding moves us up, subtracting moves us down. Let's use what we've just learned and see how we can use it to graph the absolute value function with a shift in it. First step you're going to want to do is make a table with 3 points for the parent function, and not just any 3 points are going to do. You're going to want points that have that point on the v of the absolute value. So I would use that table that you made in the beginning in the warm-up, -1, 1, 0, 0, 1, 1. That has that nice little turnaround spot of absolute value. Next, we're going to make a new table based off of this, except we're going to use the transformation in that new table. So I'm making a grid here for my new table, and my transformation, -4 inside here is telling us that we are shifting to the right 4. The -2 outside is telling us we're shifting down 2. Again, inside is left, right, opposite. Outside is up, down, same. Since I'm shifting right 4, that means I have to add 4 to all the x values when I'm actually calculating my new points. And if I'm going down 2, that means I'm actually subtracting 2 from the y values. Let's go ahead and apply those now to the x and y values. So we've got -1 plus 4 is 3, 0 plus 4 is 4, 1 plus 4 is 5, and now let's subtract 2 from all the y values. 1 minus 2 is -1, then we have 0 minus 2, and 1 minus 2 again. Now all we have to do is graph those points. So we've got 3, -1, 4, -2, and 5, -1, and make the absolute value through those. That's one way of doing it. It is also possible to graph the original, graph these 3 points actually on here, and then visually move them. So this point we're going right 4, down 2. The origin moves right 4, down 2 as well, and also this other point. And you might be thinking, well, that sounds a lot easier than making this table and regraphing everything. And for this problem, it might be, but we're going to be doing multiple transformations at once, and I think you're going to find that this table method actually works much better when there's more going on. Let's take a look now at a function where there's more than just one thing going on, and we'll do a kind of a pseudo real-life application. So Batman wants to purchase a vigilante license so he can go after bad guys legally. The cost of the license depends on how many years it'll last for, as determined by the formula below. Now, Batman wants to figure out, should he keep renewing every year, or should he get a license for a really long time? What's going to cost less? So we're going to go ahead and sketch the function so Batman can decide whether to get one license for a long time or renew every year. So here we go. Woohoo! So before we dive into doing this one, pause the video for a sec and see if you can just figure out what's happening to the x and the y values based on this transformation. All right, let's see what we came up with. So this 2 outside here is going to be stretching us vertically, multiplying the y values by 2. This +4 inside is going to be shifting us left 4, subtracting 4 from all the x values. So let's go ahead and do that now. We need a table to start with, though. This is the square root function, so we're going to use that table with our 3 square root points, 0, 0, 1, 1, and 4, 2. And if you forget these, you don't have to memorize them. I mean, it's just the square root of 0, the square root of 1, and the square root of 4. And I picked these numbers because they're easy to square root. So transforming those now, we said that we're subtracting 4 from the x values, and we're multiplying the y values by 2. Pause the video, go ahead and apply those transformations to the x and y values. So for the x's, we should have -4, -3, and 0. For the y's, we should have 2 times 0 is 0, 2 times 1 is 2, 2 times 4 is 4. And graphing those out, we got -4, 0, -3, 2, and 0, 4. And make the square root function through those. Now, I think you'll agree this one would have been a little bit tougher to do just by moving points around. It's still possible, but the table, you're less likely to mess up. Now, having said that, if you graph something from this table that looks completely not like a square root function, then double check your math. Whatever this ends up looking like, it should still have that square root shape. Let's do another one with even more to it. In this one, we have this negative outside, so that's going to be a vertical reflection. The 2 inside means we're going to be shrinking by 1/2 horizontally, and this +3 shifts us up 3. So let's write down all that stuff, or at least make a mental note of it. And now our parent function again is 001142. Let's make our new table. So for x values, we're multiplying x by 1/2. We're shrinking this horizontally. So we've got 1/2 x. And for the y values, two things are actually happening here. We're multiplying y by -1, and we're shifting up 3. So here's what that's going to look like. Now you'll notice that this negative is going to happen to the output before we add 3. Whenever you're doing multiple transformations, reflections and dilations, because they are multiplication, always happen before translations. Multiplication happens before addition and subtraction. So let's go through and apply that now. 1/2 times all of that gives us 0, 1/2, and 2. And then we've got negative y plus 3. So negative 0 plus 3, negative 1 plus 3, and negative 2 plus 3. Graphing all that, 0, 3, 1/2, comma 2, half grid line, and 2, comma 1. So we have an upside down square root function that has been shrunken a little bit horizontally and shifted up. If you have the time and the inclination, pause the video and try this one all by yourself, then restart and we'll see how you did. All right, so for our transformations, we have a negative inside, so this is going to be a horizontal reflection. And since you have this 1/2 inside, we're going to actually multiply by the reciprocal, 2. So the x values get multiplied by -2 then. Outside, we're subtracting 5, so we're shifting down 5 here. So there's our square root table that we've done a few times now. X values are getting multiplied by -2. Y values, we're subtracting 5. So for our x values, we've got 0, -2, and now -8. And for the y values, -5. 1 minus 5 is -4, and then we have -3. 0, -5 right there. -2, -4 right there. And then -8 over here, -3. Yep, there it is. There we go. So you can see how a table is very helpful when you have all of this going on at the same time. Hopefully by now you have completed your transformation into a dilating, reflecting, shifting machine. Until next time, this is Mr. Sutton signing off.